Welcome back to Code and Current Studio. And in this tutorial, we're kicking off stage one of our Arduino vehicle cooling and automated AC system project. This series is designed to simulate a realistic automotive HVAC behavior using sensors, actuators, and LCD displays. Stage one focuses on monitoring engine coolant temperature and controlling a cooling fan and warning LEDs based on that data. For this project, we'll need the Arduino board, temperature sensor, the DC motor, the NPN transistor, a yellow and red LED, 220 ohm resistors, a 1K ohm resistor, the LCD display, and a breadboard. We'll start by wiring in the temperature sensor to analog pin A0 to read engine coolant temperature. The LCD screen connects to Arduino via SDA and SCL pins to display real-time temperature readings. Both the temperature sensor and the LCD require 5 volts, power, and ground. A DC motor is connected to digital pin 8 and will activate when coolant temperature exceeds 90 degrees. The motor circuit includes an NPN transistor and a 1K ohm resistor to safely switch the motor on and off. Two LEDs provide visual warnings. The yellow LED turns on at 95 degrees Celsius and the red LED at 100 degrees Celsius. This setup mimics how a real-life vehicle responds to overheating conditions. Let's take a look at the code. The code reads analog input from the temperature sensor and converts it into both Celsius and Fahrenheit. It then displays the temperature on the LCD screen, which must have its I2C address correctly matched in the code to ensure proper communication. The logic activates the fan when the coolant temperature reaches 90 degrees Celsius, illuminates the yellow LED at 95 degrees Celsius, and turns on the red LED at 100 degrees Celsius. Conditional logic is used to check whether the temperature has changed before updating the LCD, which helps reduce flickering and improves display performance. All right, let's double check our code, start our simulation. You can see the coolant temperature sensor is displaying the temperature. We can see that our fan is currently off. So if we adjust our temperature up to 92 degrees, we can see that our fan turns on. Anything over 90, adjust it a little bit more. We can see at less than 100 degrees, between 95 and 100, our yellow LED illuminates. And then anything over 100, our red LED is going to illuminate. Try adjusting the temperature sensor input to simulate different coolant temperatures. Can you modify the code, possibly add a buzzer when the red light turns on, or log temperature data over time? Share your ideas and enhancements in the comments below. If you're following along, consider picking up an Arduino starter kit. It includes all the components we've used so far and more to challenge your understanding of the Arduino and the code. Check the description for links to the kits and components. That is it for stage one. You've now built the basic engine cooling simulation using Arduino. Don't forget to like, comment, and subscribe for more Arduino tutorials. In stage two, we'll add cabin, temperature monitoring, and desired temperature input. So stay tuned.